Hi, welcome to Build with DynamoDB. Today we're going to talk about um, when I should use Amazon DynamoDB or Amazon DocumentDB with MongoDB compatibility. And I have a guest, Jeff Duffy, who goes by Duffy, who's also a specialist for Amazon DocumentDB. Duffy, welcome.
Thank you.
Great to have you on the show.
Good to be here. Thank you.
Also, we have Daniel Yoder, a coworker of ours, who's moderating in the chat room. Feel free to ask us any questions you have on the topic for today. And with that, I think we can jump right in. Duff, you want to tell us real quick what Amazon DocumentDB with MongoDB compatibility is?
Yeah, so Amazon DocumentDB with MongoDB compatibility is a MongoDB compatible service. It's fully managed, it's fast, it's scalable. And by MongoDB compatible, what we mean is it's not a drop-in replacement for MongoDB. Rather, when we built the service, we listened to customers and they told us the features that were most important to them, and we built those into the service, and that's what was available at launch. And we by the way publish very clearly in our documentation, sort of which features today we support and which ones we don't. We can put a link to that in the chat. But it provides a way for customers who want an AWS managed document database to easily have access to a database that can help them build the applications they need.
Right. And it's by now it's just under a year old.
Yeah, I think we're about 8-9 months from GA. We went GA on January 9th, I believe.
So far, what would you say some of the most common use cases for DocumentDB are?
Yeah, so we see customers use DocumentDB in almost every industry, but I definitely would say, for instance, probably our most popular customer set comes from the gaming industry. Because as you know, document databases are popular because they have both a flexible schema and you can query them very flexibly, which is really useful when you're thinking about doing things like storing user profiles for your game or maybe your game states. We see it in gaming for things like game platforms. We have customers who have game platforms where they will have to vet the games that will be deployed on their platform to understand the different attributes about those games and so forth. And document databases are really good for being able to not only store the data they need to store and query today, but also kind of change with them as their game or their platform evolves.
Right. And that's really interesting too, because as you might already know, we talked about on previous shows about use cases for DynamoDB, and gaming industry is definitely one where customers use DynamoDB as well. We've written about it and so on, and now I think you can see why we kind of want to talk about why would you use one and not the other, and what do you use to decide which one to use, right? That's really interesting, and for DynamoDB. So again, gaming is one industry, right? Overall, I would say as DynamoDB is used in quite a few industries. In fact, we see use cases that go from retail to ad tech to financial banking industry and so on. One thing that they all have in common is that sort of internet scale, right? Where they need to really scale not just data volume or traffic, but it could be number of connections, number of concurrent connections, and so on. And another sort of pattern that we see with DynamoDB being part of serverless platform, you really can use it in use cases where that's sort of key, to have a serverless architecture with no instances to think about, and so on. And I want to say one sort of thing that we don't see enough with DynamoDB is using it in use cases that don't necessarily require scale, but still require maybe high availability, the level of availability and durability that DynamoDB is built for as well. And that said, I think back to you, right? I'm curious to know about some of the maybe just kind of characteristics of use cases or workloads, maybe in terms of features that draws people to use. I mean, is it really because they're familiar maybe with MongoDB API? Maybe they're using MongoDB on-prem or maybe even on EC2, or maybe it's a shop that's even thinking about new workload but is very familiar with MongoDB API.
Yeah, so certainly, of course, we talk to a lot of customers who are using MongoDB on premise today and who are interested, in an AWS offering a managed service, and that's why we built DocumentDB. So in terms of the characteristics that make it attractive for them, I think flexibility is the word that really best describes what they're looking for. So it is definitely true. The MongoDB API is very rich. It's very powerful. There are a lot of different features that you can use. But of course, that's true for a lot of other databases as well. I think the thing that really drives customers toward wanting that document model is both the ease of use and storing the data. You don't have to think a lot up front about what you want to do when you want to store your data. Now, of course, that flexibility doesn't mean you still don't have to consider your workload and think about what you're doing critically. But generally speaking, there's not a lot of schema design necessarily that has to happen up front. You can, more or less in your sort of early stage greenfield part of your application development, just sort of, put your data in there, start to use it, let your application grow and develop, kind of figure out how you want to ask questions of your data. And the second part of that flexibility comes in there, which is the query, right? So it's an extremely flexible query model, both in that, of course, you can query on basically any field, and that includes nested fields, right? So the document model allows you to have nested fields of lots of different types. DocumentDB specifically, we let you go up to 100 levels deep. And you can query on those nested fields. You can build indexes on them. And so that's like a really flexible query model for customers, especially as their applications grow.
But that, again, being another NoSQL or non-relational database, you do want to know sort of some of these access patterns, right? So that you can build indexes. Sure. Because you will need those indexes again.
Absolutely.
Yeah.
So the flexible storage and query model that document databases offer, I guess I would say, allows you to evolve a little bit more easily than maybe some other database types. But of course, it's important always to think critically, and as much information you have about what your application's going to do, what your schema is going to look like, especially as you've said, what your query patterns are going to be in order to decide, your indexing strategies. And it's not really just about indexing. I mean, of course, your data footprint management, things like that all sort of come from your decisions too. So.
Right. What are maybe some of the questions that you get the most about Amazon DocumentDB when you talk to customers?
So probably most commonly it's going to be about the level of compatibility, I think, and the second is going to be the architecture. So as I said, we're not a drop-in replacement, though we do have, significant compatibility with Mongo in terms of feature set. And of course you use the same drivers, so there's nothing new to learn from that perspective. And so often we have conversations about, do you support this particular feature or that feature, which is why we have that list of features that are supported in the docs. But that aside, which is a pretty easy conversation, it's about the architecture, because the MongoDB architecture is fundamentally different than that of DocumentDB. And so performance envelopes are going to be different. Maybe some of the things that you're going to think about from an operational perspective are going to be different. And it's a managed service, so your operational burden is lower. You've got a lot less to think about, but that doesn't mean nothing, right? So there's still considerations to be made about how you want the service to operate, backups, point-in-time recovery windows, things like that. Yeah.
Right. And as always, right, every good architecture is built around cost objectives, right, as well. And would you say that cost effectiveness is one of the sort of points that DocumentDB really delivers on?
Yeah, so certainly cost optimization is important to every customer, of course, right? And I would definitely say that we have guidance and have conversations around how to optimize costs. So For example, we have a feature in DocumentDB called Start Stop Cluster, and this allows you to take your DocumentDB cluster and stop it for up to 7 days, after which it'll start itself again. And so that's something you probably are not going to have with a typical Mongo implementation on premise, and that's attractive to customers for sure. Yeah.
Right. And of course, during that time, you're not incurring.
You're not incurring costs, right?
Costs.
Yeah. Stop it on Friday, start it up again on Monday. Absolutely. Yep.
Yeah. So, and of course, this is a fully managed service, right? That's kind of one of the things, if we talk about some of the, let's say, non-functional aspects of services, database services. And of course, on AWS, as you know, we're all about purpose-built databases, right? And that's really the reason why we strive to have databases that fit our customers' needs, requirements. That's why we have Amazon DocumentDB. Of course, these are all fully managed databases we're talking about. Some of them are serverless as well. To me, what's interesting about the difference between the two, and this comes up quite a bit, is I see people kind of thinking that fully managed as serverless is the same thing, and it's not really. The main distinction is with serverless, you really do not have as a customer, as a user, anything in terms of instance types, in terms of availability zones. You think of a service much like you think of serverless compute, such as Lambda. You're thinking about requests, and with DynamoDB now you have the option of having fully on-demand, pay per request, capacity provisioning mode, in addition to the well-known provision mode, that is one of the things that's, for example, different between DocumentDB and DynamoDB as well. And of course, the APIs are different.
Yeah.
In the world of NoSQL, there's just no standard NoSQL API. Right. So that's just something that you have to keep in mind anyway. So when we talk about purpose-built databases, right, and polyglot persistence, how much of that do you see with customers that you work with? And I'm just curious, how much of let's say microservices do you see that as a trend that's maybe on the rise with use cases that involve MongoDB or related to DocumentDB?
Yeah.
As well, and can you maybe speak to any patterns that you might be able to have distilled from, let's say, those kinds of migrations, right? People may be thinking about, here's a managed service. I know the Mongo API, and I already have this as a microservice or not. And what are some of the ways that people go about that, migrating those, and maybe going from a monolithic application to refactoring them as microservices, maybe?
Yeah, that's an interesting point. There's a lot of discussion about where microservices come in and their particular value versus monolithic and so forth. And I think that a lot of people think, it's often an organizational communication thing that results in this sort of architecture, which I think there's a lot of truth to that. But from our perspective, database stuff, the things that we care about the most, the cool thing is that as customers move into that microservice architecture, and those microservices are most concerned with fulfilling a single function or a set of closely related functions, it is easier for them to take advantage of what you're describing with our purpose-built approach, which is the right way to do things, which is to say, if my microservice is focused on search, if its point is to take in some data and to go search for some data and return some results, potentially with a lot of complexities, boosted queries, things like that, that service should be looking at our Elasticsearch service because that is the appropriate backend for it, right? So in the same vein, services that want to take advantage of that query flexibility that we talked about, especially if, especially if they're coming already from Mongo on-prem or somewhere else where they're already using it, but even if they're not, if their data is best represented as a sort of, that complex document, it might be nested, it might have complex types like arrays or timestamps that best represent the data they have, then of course DocumentDB is going to be the best choice, right? Because it provides you that sort of flexibility to go in and query deep and look at those different types of data and so forth. But that said, and I think we'll cover this more in depth later, being the point of the conversation to sort of compare and contrast, when that customer's service is looking for what I would consider to be, high to extreme scale, like really high levels of throughput. If, for instance, that customer finds serverless super attractive because the rest of their microservice architecture is serverless, if it's all built on, API gateway, on Lambda, and they don't have any other sort of instance-based, components
right.
to their architecture, then Dynamo is really attractive from that perspective because it continues that sort of convenience of serverless all the way back to the data store. And DocumentDB's architecture is not serverless, it's instance-based, and so that's a component that has to be sized and scaled.
Yeah, really interesting points, right? And I think for me, what makes microservices architectures really, really valuable, where I see most of that value add, is the fact that some of these decisions are easier to make, right? Because you're carving out your potentially huge monolith, right, into a number. And like at Amazon, those numbers, we're not talking dozens, we're talking about hundreds of microservices. And it becomes a lot easier to decide what database to use for a given microservice for a number of reasons. You're segmenting that data model from one monolithic data model into bounded business contexts, and then you're more likely to be able to easier identify what database is the most appropriate and go for it without feeling like, man, it's a huge decision, I have to pick a single database for this whole thing. And you don't, right? You can pick the right database for the right service. And I think that's one of the best things about purpose-built databases, which I think, the whole thing started back when it became pretty clear that you can't use relational databases for everything anymore, right? And so that gave rise to NoSQL movement, which we now call non-relational. So here we are, right? With how many databases that we can talk about just on AWS.
Yeah, for sure.
Yeah. Any other use cases that sort of you see people using DocumentDB?
Yeah. So retail, we see a lot of retail sales use of DocumentDB for a couple of reasons. I think one is, again, the combination of the flexible data model and the flexible querying is really attractive for customers who want to do things like, we have customers who they'll first itemize their store locations, and then they'll use that to help them bond and track inventory for promotions and so forth. And especially some of the larger customers, they'll acquire another company, and then the store's types will grow, and it's really easy to go in and just modify the data set in order to reflect those changes that have happened to their company, and then reflect those in the changes that they make to how they have to query it, without having to really make too many changes to the application. It's often just as easy as adding an index to the appropriate new set of information they have in their documents, and away they go. So yeah. We also see, because of that flexibility, a lot of sort of media news. We've got several very large customers. So content management generally is a very popular use case for document databases. And so, of course, we see a lot of content management based use cases and applications that use DocumentDB because, again, like that extreme flexibility of querying is important when you're talking about content management with all the things that you might want to do with it. So yeah.
Right. And that too is interesting for me because, we do see DynamoDB used in those verticals
Yeah.
as well. And in fact, we've got a couple of blog posts, in fact, that specifically maybe focus on some of these ad tech gaming, but a couple of shows, we did the whole show that's dedicated to using DynamoDB across various industries. And I think it's interesting to see basically that, for some use cases you would go with DocumentDB because of the ability to work with documents that you get with DocumentDB being really rich in the document API,
Yeah.
right? I'd contrast that to DynamoDB, which also has document API, which does not offer same level of features, right? The ability to query, like you said, nested, right, attributes and so on. For truth be told, right, we've offered workarounds for this kind of thing, right? Sure. There's a way to make things work. I mean, there's a way to make anything work if you have to, right?
Sure.
But I think having a fully fledged document API and that's a first class citizen document database is definitely a valuable thing for us. And of course, the API that's compatible with the most popular database out there clearly makes it that much easier to adopt, right? On the other hand, I will say that by and large, when we see people that opt for DynamoDB, it's because of the scale, typically that they need. One, two, the kind of availability, right, that you get, with now, some of you might know, we talked about this, 4 nines of availability within a single region, right? And then if you need that global presence, right, with multi-region replication now, that's been available in DynamoDB for a while, you're actually able to get 5 nines of availability when you use global tables with DynamoDB, and what's interesting, I think, is that the scale is rarely only by a single dimension, such as data volume, right? It's often the volume of reads, the concurrency, read-write volumes, the ability to elastically handle spikes in the workload, right? I mean, I'd have to say that probably the best known use case for that is Amazon.com with events such as Prime Day, right? I mean, I think this Prime Day, I think we peaked at a like much higher request rate. I would say 46 million requests per second just during the Prime Day. But companies such as Nike, for example, another retail e-commerce platform, they also have really interesting problems that DynamoDB helps them solve very, very efficiently in terms of the ability to handle spikes in the workload, and while providing that same latency, right?
Yeah, those are important differentiators for sure, because the architecture is fundamentally different. So DocumentDB can still offer 4 nines of availability, but in order to get that, you have to have at least 3 instances deployed across 3 availability zones in a region. So that's some thinking you have to do up front when you're planning your deployment and so forth. And as you've said with Dynamo, you just sort of get it right by using the service, which is nice. Scale, I think, is a really important differentiator. I agree. So DocumentDB is very fast. I mean, it is definitely highly performant. We can push definitely tens of thousands of writes a second through a DocumentDB cluster, and so we can scale reads by adding read replicas. You get up to 15 of those, so 16 total instances in a cluster, and that means that you can read millions of reads per second from a DocumentDB cluster. But it is absolutely true that there is a scale at which a single DocumentDB cluster simply cannot process the traffic as fast as some customers need it to. And so, some customers may choose to simply basically shard in their application and have multiple clusters. And that's a completely valid approach if your workload is okay with that, and some are. But yeah, absolutely. There's no other database in the world that's going to scale the way that Dynamo can in terms of just pure throughput. Right. And so the last point that you made is an important distinction as well, I think, which is the sort of natural affinity that Dynamo has to dealing with extremely variable workloads quickly, right? Really bursty, going from very little traffic or none to extreme levels of traffic and then back down again. So because DocumentDB is an instance-based service, while it does scale easily because it's, again, nothing the customer has to do. Sure. They call an API and they can just add instances to scale reads. There's still effort required on the customer's part to either write that Lambda function to do it for them or so forth. So there is some, I guess, customer action to scale. And the scaling is, while easy and fairly quick, it takes us like 8 to 10 minutes to add an instance to a cluster, is still probably not going to be nearly as responsive as Dynamo, especially if you're using the correct Dynamo mode, right?
Right. And of course, instance-based, again, comes down to instance-based versus serverless. I mean, and in that respect, DocumentDB is much like other instance-based databases that we have. Very similar behavior in terms of how you do capacity planning, right? Determining your just kind of the right instance type, right? And then how many replicas do you need, and and it comes down to what your HA requirements. What are your DR requirements, HA requirements, in addition to maybe read, right, or scaling requirements for your read throughput.
Yeah, absolutely. So it's worth noting that one of the nice things about the DocumentDB architecture is that it's highly durable even if you only have a single instance. So our instances exist so you can read and write your data, but they're not data bearing themselves, which means that you can have like one instance, run really small workloads, do what you need for dev test, and then just add a bunch if you want to with a few button clicks, API call, and add some more. But that is an important distinction. You're absolutely right. Capacity planning must take into account instance size from both a read and write throughput, also working set, right? So we have a working set cache that lives on the instances that the queries will use if the database information is already in that working set memory. You've got to think about that too for capacity planning. So that's certainly a differentiator.
You're best off if you can serve, obviously, everything from the working set. Right?
And the good news is we report a metric to CloudWatch that will help customers find out whether or not they're making good use of that. So at least it's not terribly hard to understand, but it's absolutely a consideration.
I'm actually not very familiar with the metrics that you have for DocumentDB. What other metrics would you sort of point out as sort of some of the key metrics that you want to watch?
Sure. So we can think of the metrics that we send to CloudWatch in two groups. There's the cluster overall, because a cluster is composed of our storage volume and then the instances that you use to talk to that cluster. And so in our cluster level metrics, we report things like, for instance, the maximum replication delay between our primary instance and our replicas, which will tell you, because reads from replicas are eventually consistent, they will tell you the maximum amount of time that they will be eventually consistent too. Important metric for some customers who kind of want to set an alarm on that and say, I don't ever want this to be longer than 100 milliseconds. So I understand I have some upper bound on what my eventually consistent reads are. Sort of like Dynamo, you can do read after write consistency in DocumentDB, but you have to read from your primary instance. I know in Dynamo you get to choose, right, when you're doing your reads.
Yeah, but it really comes down to if you specify the strongly consistent option, it really just sends that request to the leader, to the primary node for that particular key, right? I mean that's the main pattern, right? For doing read after write, it's like you serve that read from the writer, basically.
It pretty much works the same way in DocumentDB. Right. It's just that you let the driver take care of it. You tell the driver if you want, replica reads or primary reads. But yeah, absolutely.
And so in terms of that convergency, what's sort of typical for regarding consistency, right? You're saying that's something that you can sort of indirectly control.
Sure.
Right?
Yeah.
What would be sort of the main way of affecting that and saying, well, okay, I need to, let's say, lower the propagation delay to, to replica nodes or whatever. What can you do as the user to affect that?
Sure. So in the drivers that you're going to use to DocumentDB, the Mongo drivers, there's a setting called read preference, and you can make that setting when you create the connection pool, and you can also apply the setting when you're making a single query. So you can kind of choose which way you want to do it. And the default just goes to your primary. So every read is read after write consistency. But of course, and you're not making use of all the replicas that you've got running, right. Maybe just even for availability's sake in order, to take advantage of higher read throughputs. And so you can make another setting to that read preference where they have like secondary, which only goes to the replicas, secondary preferred, which will go to the replicas unless there are none, and then the primary, which is what we recommend in our documentation. But that's how customers control what kind of read they're getting, and luckily the drivers are sophisticated enough that you can choose whether it's always or when you're doing a specific query, which is kind of nice. In terms of replication lag and delay between the primary and the replicas, so that mostly comes down to the size of the instances and the load that you have on your cluster. So typically speaking, replication delay goes up if you have a heavily loaded primary, because that primary is, and I'm simplifying, more or less kind of telling the secondaries, the replicas, hey, this is the current state of the database. Well, the more heavily loaded it is, the longer it may take it to tell those replicas what the current state is. So increasing replication delay is actually one of the indicators that it may be time to think about scaling up your clusters to larger instance types. Yeah, absolutely.
Yeah. What's the most common instance type for, let's say, production?
So definitely the R5 family. So we support the R4 and R5 instance families in the US at least. Some of our other regions are R5 only. And of course, you should always use R5s because the cost is the same as the R4s,
right.
But they're a lot faster. A lot faster,
type.
absolutely, yeah. So just picking within that R5 family from large to the 24x large, which is pretty big. And that sizing comes into what you were talking about before, my average read and write throughput that I'm considering, what kind of working set am I going to need in order to keep all my memory and my data and working set memory. I mean, that's kind of the guidance that we give to customers to pick the right instance type.
Right. Yeah. And I mean, the amount of RAM, obviously, for the working set size, that's kind of one of the key considerations.
Yeah. So you get 2/3 of your RAM is working set memory in the, let's say, the 3 or 4 smaller instance types in the family, X large, 2X large. Above that, you get a little bit more. We don't take, or it doesn't take 1/3 of an R424XL's memory to run the engine. That third that's used is for the actual engine itself under the hood to kind of run your database, But yeah, so you start with about 1/3, it grows a little bit. And most customers that we talk to are able to make some pretty educated guesses once we take a look at, we look at things like their average document sizes, the query patterns that they have, and can make some pretty good guesses at it. And of course, since we're reporting that metric, it's very easy to go watch it in your dashboard in CloudWatch and say, it's called buffer cache hit ratio. It's reported in terms of the percentage of what's read from working set memory. You want it to be 100%, as you said. So, every workload is different, but if it's pretty low and making a bigger instance type makes it go up, typically means, you need more working set memory in order to effectively serve your queries. Yeah.
Right. Yeah. So drawing. Here's. Okay. Here's a question that we're seeing. It says, for someone not as computer literate, what is it? One sentence. DocumentDB versus DynamoDB. All right. Let's go at it again. The question being, for someone not as computer literate. What is it? One sentence. DocumentDB, and then I'll do DynamoDB.
Yeah, so DocumentDB is a fully managed MongoDB compatible document database. That's what it is. And so, as we said, document database is all about storing data in documents, which are basically JSON structures, keys and values, hold your information. They can be nested, they can be complex, but it's a managed database engine that lets you index and query that data flexibly so you can do what your application needs.
Right.
Yeah.
Amazon DynamoDB is a key value database that's also fully managed as well as serverless, meaning you don't think about servers at all. You think in terms of read and write requests, right? That's designed to scale basically without limits, right? To any data volume or read or write volume, and deliver same single-digit millisecond performance for what we call singleton operations. These would be your get item, put item, or delete item operations. And so, again, what's interesting about it is, if you're really curious about NoSQL or non-relational databases, they are both key value databases under the hood, basically. But document databases tend to have richer document APIs. APIs that allow you to query nested attributes, structures within, for example, JSON documents, as is the case with DocumentDB. DynamoDB, interestingly enough, also has a document API, but this API does not allow you to query nested attributes and so on. And so, for a while, of course, we have workarounds how you can do that and whatnot, but it's just not the same thing. Basically, they're very limited in that sense. DynamoDB is designed to scale. We say infinitely, right? But one of the key key points to that is that in order to be able to scale like that, you do have to give up on complexity, on richness of some of the let's say querying API and so on. Namely, because when you query DynamoDB, you're always querying single node. You always query based on the partition key, and that's how you can really scale it practically infinitely, right? So querying it's very important to get right, so that you really can enable that scale, and in a way that's also cost effective. As you scale, your cost should also grow linearly, so proportionately to your workload. So hopefully that explains kind of, and I would say in addition to the API differences, right, the other sort of key difference is how you look at capacity, right? And that's true not just between DynamoDB and DocumentDB, but generally between serverless and instance-based services, right? Whether it's compute, where you can compare Lambda versus managing your EC2 instances, right, that you fully control, and database is the same thing. You have services that are serverless, where you have to think about your workload in terms of read and write volume, versus if you have instance-based services, then you do have to decide what's that instance type, what's my unit of scale. That's your single server, and then you have to decide how many do I need, what is my HA requirement, what is my disaster recovery requirement, right? And based on that, you figure out what your instance type is, and then how many instances you need.
Yeah, and so that comes into play with, as you said, capacity planning. It also comes into play with limits, right? I mean, limits matter.
Right.
I don't think they're a defining characteristic of what you should use as your criteria for choosing a database, but they are different between the services. So, for example, DocumentDB has a storage volume that grows automatically, so the customer doesn't have to do anything to have that grow. But they have a limit at 64 terabytes, and it's actually 32 terabytes for a collection, which is kind of like a table. And so those are decent limits, but they do exist. And so if a customer knows off the bat, well, I have a lot more than 64 terabytes of data that I want to introduce into the database and query on regularly, then maybe Dynamo is a better choice for that particular workload because that limit is not suitable for DocumentDB. So other examples might be, we kind of talked about the throughput limits that exist.
Right.
You mentioned workloads that have lots of connections. I find, so two things are true. DocumentDB has connection limits on a per instance basis.
Sure.
The number goes up depending on how big the instance is. Like our smallest instance types, you can do 1,100 connections. Our largest instance types are I think 4,500 connections. That said, typically speaking, we sit down with customers. This doesn't end up being like a really big limiting factor in terms of whether or not they can use the data store. I think the difference comes down to for like those microservices workloads you were talking about. So those will tend to deploy lots of containers, and those containers will tend to deploy lots of workers that might not do a lot of work themselves, but they'll use drivers that will build connection pools, and those connection pools will have these sort of default settings that'll use a lot of connections, and so
so connection pooling is one of the patterns that you can deploy to manage essentially. Connections are a resource, right?
Right.
So
So in this case, we often have to have a conversation with customers and say, make sure you're not leaving the defaults, but thinking about what you're setting those connection pools to, because if this container needs 4 connections and it's building 200, then you may run out of connections pretty quickly. Sure. Whereas necessarily the workload itself has not resource constrained, but the deployment model is. So that's certainly something customers have to consider. And as you said, not really a consideration for the serverless model, right? Because they can just do what they need to do. So
right. And in fact, one of the things that I was going to point out too, though, instance-based versus serverless, right? But with serverless database like DynamoDB, you do have to think about some of the limitations as well. Such as hotkey is maybe somewhat of a more prominent concern than it might be with instance-based, and it's simply because when you partition in a way that serverless services partition workload, you get partitions that are smaller than a single instance.
Right.
So, and there are really good reasons for that, right? You smaller partition is a key to having that elasticity, the ability to react quickly to changing workloads. But at the same time, if you do have that hotkey, then you're subject to maybe a more prominent case of a hotkey that you would have with your own instance-based, let's say, cluster.
Sure.
That said, with DynamoDB, that's always been an area that the service has been improving over the years, right? We talked about adaptive capacity for DynamoDB, which dynamically manages the traffic and allocates more capacity per instance. And to me, that's one of the most exciting new things about DynamoDB, over the last couple of years, in addition to things like global tables and, built-in support for backup and restore being another one. Speaking of that, in fact, backup and restore is something that comes also built in for Amazon DocumentDB.
It does.
Well.
So it's turned on by default. The service supports point-in-time recovery, and you actually get 24 hours of that just sort of out of the box with the default settings, because we aim for intelligent, safe defaults. You can expand that window up to 35 days, actually, for point-in-time recovery. In addition, of course, sometimes we have customers who have these regulatory requirements that say, you have to keep this data around for 7 years or what have you.
Right.
So they can just go take a snapshot of the cluster and just leave that there for 7 years, and they have the data available to them.
Right. Yeah, and that's in fact one of the reasons, regulatory compliance, right? That drives features such as backup and restore, encryption.
Yep.
For example, and I'll say what you get from DynamoDB in terms of encryption, right? For a while now, DynamoDB has supported encryption at rest. Data is by default encrypted in transit to DynamoDB as well. In other words, with DynamoDB, as you read and write data, the full path is encrypted by default. What about DocumentDB?
So DocumentDB supports encryption in transit with TLS between the customer's application and the instances that they communicate with. It is not currently encrypted between the instances and the storage volume yet.
Okay.
But clearly we've gotten a lot of feedback from people that's something that they would like. It's worth noting that that's not a constraint on our ability to be compliant with certain regimes. So DocumentDB is compliant with, SOC 123, HIPAA, PCI DSS, several of the ISO compliance programs. So certainly customers can build HIPAA compliant, PCI compliant applications with DocumentDB.
Yeah.
From an encryption at rest perspective, we support encryption at rest. The service uses KMS, so customers can bring their own key material if they want to.
Okay.
And that counts for all of the places that the data might rest. So that's, instances, they're not data bearing, but they do have EBS volumes for sorting and so forth. And so that'll be encrypted. Your storage volume will be encrypted, and the S3 bucket that your backups are streamed to will be encrypted, and your snapshots will be encrypted. So all that data at rest is encrypted if you choose that option, which again is on by default. Yeah, with DocumentDB.
Right. So you get really good compliance coverage with both.
Yep.
DocumentDB and DynamoDB. So yeah, very very important for a lot of customers. In fact, so so just checking a little bit on any new questions. We were about 46 minutes into this, and we haven't had a whole lot of questions. I sort of expected.
I often get asked about pricing, so I think that's worth talking about for a moment. So DocumentDB is priced in 4 dimensions. You pay for those instances that you're using that are running. So however many you have and what their sizes are will kind of dictate what that pricing is. So we charge for I/O between the instances and the storage volume that stores your data. It's I think like in the US it's 20 cents per every million I/Os. The third dimension is the storage itself. Very inexpensive, by the way, but we do charge for it. So I think it's like 10 cents a gigabyte a month in
for storage.
For storage. And then finally, our fourth is backup. So you get 100% of your backup storage for free. If you've got 30 terabytes of data stored, you get 30 terabytes of backup for no charge. And then if you have other backup storage, like that snapshot we were talking about, we wanted to save for 7 years. Again, very inexpensive. So in the US, 2.1 cents a gigabyte per month for backup storage, which is very inexpensive. So that's what the pricing looks like.
Right. Yeah. So for DynamoDB, the components that go into price, the key components are storage, then reads and writes, and then of course the price will be different between the 2 capacity provisioning modes, between provision mode versus on demand, right? And the benefit, of course, to using on demand is that you don't have to worry about provisioning capacity ahead of time or figuring out the consumption model, right? You just create a table and you're ready to go. But you do have to pay per request. Then, of course, there's pricing for global tables, which is slightly different as well. What I do like about how it all works with DynamoDB is, to me, to be honest, and it's not just because I'm actually working with DynamoDB, but having worked with some of these other technologies, databases, and so on, it's by far the easiest database to estimate your cost with.
Yeah. Because
I technically just need the storage, reads, and writes, and the size of reads and writes, and I can get a ballpark. And when I do that, if I'm not sure what my data looks like and I can't really estimate the size of my result set for queries and so on, maybe I'll do a couple of estimates, kind of low ball and sort of low end and high end estimate, and then I have sort of like a range within which I think my price will fall.
Yeah.
Right. How do you estimate cost for DocumentDB? Because you do have I/O, you do have obviously instances. That's kind of fairly easy to estimate. But,
sure.
But then it's like getting to that instance and how many do you need might not be as easier.
Yeah. So that's fair. So today it's an interactive conversation with the customers often, where knowing what those components are for the pricing that I just talked about, you have to either the customer does this on their own, or we have a conversation with them often to do that as SAs, and you find out okay, they're probably going to need 3 R5 X large instances because they want the 4 nines of availability, and that's what it's going to take to drive the write and read throughput that they need. And then from there, we can typically figure out, what the average document size is and calculate I/O. So the I/O calculation is clearly a few steps, right? It's not nearly as simple as what you're describing. Our writes are 4K, our reads are 8K, so you have to take those numbers and figure out how many IOs they're going to incur for your documents. And of course, you have to figure in, we have that working set cache, so we don't charge for reads from working set cache. So if you have a high number of reads from the instances that are served from that buffer cache, well, you're not paying IO for those, so we don't need to calculate for those. And so forth. We take the numbers at our best guesses and do the math. Yeah.
I would say an estimate is one thing, and it can be certainly helpful in informing right your cost, right, what it might be, but to really get at the correct sort of numbers, more accurate numbers, I'd say you'd best off doing some testing.
Absolutely.
Right? And sort of maybe iterating a little bit, and I don't care what database you use, but knowing your workload, right? What are the types of queries, reads and writes that you have? How often we talk about velocity, right, of data, which really means how many queries of a certain type am I doing? What's going to be my most important, my most prominent type of read and write, and so on. What's the request size, right? Both for reads and writes. How much am I reading? How much am I writing?
Yeah.
Right? It's always these are the kind of questions that I think you really want to ask yourself and try to answer to really understand.
One of the things I find interesting about that is that customers almost always start this conversation with performance. Like you have this conversation, we're trying to help guide them to the right choice, and it almost always starts with, well, I need to write this much or read this much. And this is important, absolutely, either from a sizing perspective or even can this service drive enough throughput for what I need. But typically, what you actually find being the differentiator for what data store to choose is not necessarily how much data I need to push through, but what are the kinds of questions I'm going to ask of my data.
Absolutely.
That is really at its heart the core thing, because there are questions that you're going to want to ask of your data that a document database is really great for. Like we talked about some use cases in different industries, like the gaming user profile, right? So it is really common to want to have deeply nested complex documents, and they want to ask questions of that deeply nested document database. That's what you want. But to compare that, I'll have questions with customers or conversations with customers who will say, well, actually, the questions I want to ask are like really simple. Like I only ever actually want to go get 1 or 2 pieces of information. I just want to do it really quickly, and I'm going to do it constantly, and it's never going to be the same piece of information, which is an important consideration from a caching perspective. And then, Dynamo is an obvious choice for those use cases, because what you understand is they don't really need any of the flexibility a document database offers them. What they want is to be able to very easily, quickly, and efficiently just go retrieve chunks of data that may differ every time. But they want to be able to understand that they don't have to think about a lot else with the serverless approach that you talked about. So,
when you get to a certain scale, it behooves you to simplify your access patterns. I mean, complexity just in general doesn't scale. That's sort of one of the, I think, truths, if you will.
Absolutely.
Especially in distributed systems, right? I mean, if you tell me that you can scale out distributed joins, right? I'm gonna tell you I don't think so. I mean, that's so and that's kind of where you have to start thinking about these trade-offs, right? Some of these trade-offs. What's more important, right? And what do I need to do to accomplish my goals, right? And so then you're looking at okay, maybe I can get away with something that's different. And like on this show, we talk about various ways to work around, right, and patterns that we can implement when we're doing data modeling
Right.
in DynamoDB that allow us to scale that workload. But then it does put responsibility on user on the user to get that data model right. But for that matter, I think you got to get that data model right no matter what database.
That's true.
Some
are a little more forgiving of making mistakes than
Right.
others, but it's important to
Right.
think about that no matter what. And I think that cuts to the heart of one of the core decision points, differentiators between these two databases is that, I think that Dynamo provides extreme scale. It provides a lot of features that you don't get with other databases. Global Tables is a great example. So
Right.
DocumentDB does not yet provide cross-region replication or any kind of cross-region,
Right.
data copying. So if that's important, clearly, that's going to be a decision point. But ultimately, Dynamo asks the customer to sit and think and make some decisions up front about
Right.
what
Absolutely.
their data is going to look like, what the questions they're
Yep.
going to ask of it in exchange for those benefits.
Right.
DocumentDB is a little more forgiving up front. It doesn't ask you to think quite as hard up front. But again, you're making some trade-offs in exchange for that flexibility because, you're not getting that extreme scale and potentially some of the
Yeah.
features aren't available yet in the database.
Yeah, one other thing that I sort of feel DynamoDB doesn't get much coverage about, so to speak, in the world of use cases.
Yeah.
Not really use cases, but sort of, for lack of a better word, right? I'll say use cases is, when you don't necessarily need a huge, massive scale, but then you need a really reliable backend database. And it might be as simple as a service that's a configuration service, for example, right? But of course, again, in the world of microservices, right, where you're looking at a system that might have dozens, hundreds of microservices, right? Having a config service is a must,
Yeah.
right? What do you use as a backing database for a config service, right? Well, DynamoDB to me would be like number one choice, but I feel like we just don't see that end of, because we always tend to talk about use DynamoDB for massive scale,
Sure,
and for sure use it for that, but also use it for use cases where you need that reliability, high availability. Again, it's not about complex patterns, right? But things like a configuration service or other use cases where you do know those access patterns well in advance, that essentially you can use to create that data model that can be implemented in DynamoDB efficiently.
Yeah, agreed.
So yeah, let's see. We're
coming up on time. I know
Yes,
that
I was just gonna say
we've
that.
had our moderator put some links in the chat. If
I think
people
so.
are more interested in learning more about either or both of the databases. For sure.
Yeah.
Yeah.
Thank you all for watching. Thank you, Duffy, for joining us
Happy to be
today. And see you next time. Thank you.
Thanks. Hopefully you turned it off.
I think so.